Hello, Assalamualaikum and have a good day to Madam Nur Asih binti Ahmad. My name is Muhammad Taufiq Hidayat bin Hassan. My matrix number is 01DKA20F207. My team's member is Al-Baki bin Abdul Rahim. His matrix number is F2038. Next is Muhammad Irfan Ali bin Zakaria. His matrix number is F2060. And the last one is Zaim Hilmi bin Ahmad Sharifuddin. His matrix number is F2064. Today, we would like to present about standard Proctor test in Geotechnical Laboratory. First, introduction. The standard Proctor test is used to study or comprehend the compaction characteristic of soil with variable moisture content. The test is carried out to estimate the maximum load that the soil can withstand, thereby reducing the voids in the soil. The Proctor test is one of the fundamental tests performed on soil in geotechnical engineering. The Proctor test despite its simplicity, provides a reliable result for understanding soil behavior. Objective. First, to determine the optimal water content at which the soil sample can reach its maximum dry density in accordance to ASTM DC 98 12 standard test methods for laboratory compaction characteristic of soil using standard effort. Second, to discuss the relevance of the results of the experiment in civil engineering practice and to compare it with other soils that exhibit different compaction property. That's all from me. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Al-Baqi bin Abdul Rahim and my registration number is 01DKA20F2038. Now I would like to a presentation about apparatus. The first name is apparatus is 4-in mold assembly, and second manorama, and 3 balance, and next drying oven, and safe number 4, and then measuring tool, spoon, trowel, spatula for standard Proctor apparatus. Hello and hi. I will explain standard Proctor test procedure. Take a sufficient quantity of a representative soil, air dry, and pressurize it with a rubber mallet. Sieve the soil through number 4 safe and reject and the concealed material. And now close the cover pan safe to the shaking. Now put the soil on the trail. For coarse grain soil 4% interwater content of, and for line grain soil 10% interwater content is appropriate. Then mix it thoroughly. And now clean the mold. Measure its diameter and height and width without the collar. Fit the collar and compact the moist soil in 3 equal layers by the rammer with even retributed blow to each layer. Use 25 blows for 4 inch diameter and 56 blows for 6 inch diameter. Work to the total height of mold with collar. Now remove the koala from the compacted soil even with the top of the mold with a straight steel edge. Clean outside of the mold and base plate and wet it. Remove the soil from the mold, split it and take about 100 grams sample of water content determination. Break the soil lamp, mix it with a remaining soil in the trail. Add more water to increase the water content by 3% and repeat the compaction procedure to each increment of water until the mass of the compacted of decrease. And then calculate water content for each trail and corresponding dry density. Plot the compaction curve between water content as Brisca and dry density as coordinate. Note the water content. Plot the water compaction curve between water content as abscissa and dry density and as coordinate. Note the water content against the peak of the curve as optimal moisture content and the corresponding dry density as a maximum dry density. That's all for me and thank you.
Hi and Assalamualaikum. My name is Muhammad Irfan Ali Bazaira and my matrix number is 2060. So for observation and calculation, the wet density or bulk density of soil is computed as R equal to weight of compacted soil per volume of mold. After determination of moisture content of the soil, the dry density of soil is computed as RD equal to R per 1 plus M. Moisture content determination. Note number 1, WT as a weight and CONT as a container. So for example, moisture can know weight of container plus wet soil, weight of container plus dry soil, weight of water, and weight of empty container. So moisture contents, weight of soil plus mold, weight of mold, weight of soil in mold, wet density and R, dry density and RD. So for density determination, note number 1, WT as a weight, and number 2, CONT as a container, and number 3, GM equal to grams, and CC equal to centimeter per cube. So for our data, we have trial number 1 until number 5. So mass of mole plus base plus wet soil equal to 5,700 for number 1, 5,740 for number 2, 5,800 for number 3, and number 4, 5,840, and number 5, 5,900. So can label PL hashtag 3, CJJM LL hashtag 1 for number 2, CAN hashtag 5 for number 3, GKL 4 for number 4, and hashtag 2 for number 5. Mass of CAN 14.17 for number 1, 14.31 for number 2, and 14.45 for number 3, 14.02 for number 4, and number 5, 13.91. So mass of CAN plus wet soil 52.52, number 2, 57.65, 53.50.5 for number 3, 56.78 For number 4, 68.52. For number 5, mass of can plus dry soil equal to number 1, 51.91. Number 2, 55.192. And number 3, 50.86. And number 4, 52.74. And number 5, 62.2. So water 8, number 1, 126.6 for 3%, 211 for 5%, for number 2, 211 5%, for number 3, 211 5%, for number 4, 253 6%, for number 5. Water content 1.62, number 1, number 2, 4.16, number 3, 7.25, number 4, 10.43, number 5, 13.09. Gamma Y, gamma M, number 1, 15.38, number 2, 15.80, number 3, 60.42, number 4, 16.83, and number 5, 17.46. Gamma D, number 1, 15.14, number 2, 15.70, number 3, 15.31, number 4, 15.24, and number 5, 15.44. 80% saturation, 20.93 for number 1, 19.60 for number 2, 18.20 for number 3, 16.95 number 4, and number 5, 16.03. 100% saturation, 21.12 number 1, number 2, 20.02, number 3, 18.83, number 4, 70.75, and number 5, 16.93. So for the result of soil compaction test, optimal moisture content is 6.5% and maximum density 145.
For the conclusion, after performing ASTM D698, it has been concluded that the maximum dry unit weight of 16.36 kilonewton per meter cube and can be achieved using 15% moisture content and a standard effort of 600 kilonewton meter per meter cube m per meter cube. The values attained can be of great use in construction using the test sample if maximum compaction is wanted in order to support the maximum load possible. And the second one is there was no way in order to compute the error of the experiment, and thus it is recommended to perform the experiment more than once in order to provide more precise and accurate data. That's all for me. Thank you.